what we're going to do today is a little bit different than we normally would, because normally if we miss a day or just something gets interrupted, I would normally move the kind of review day back a day and let y'all work on it today, and then we would just go over it on Monday. But, well, next week is the last week of school. We're going to go on and start going over it today. We'll go through half of it today, half of it Monday, and your final chapter 5, where we at? Chapter 6 test will be on Tuesday, just with how everything's planned out. So we'll go through half of it today, half of it Monday, and then you'll test on Tuesday. Yes, because they want us to get all the grades turned in, everything graded, submitted by end of the day Wednesday. So if I can get it by Wednesday, that'll be great. Now, so what we're going to do is we're going to go through this review sheet today, and we're going to start off with these first few here. So we want to evaluate each one of these when x is -2 and when x is 3. Is there any one of these 5 that y'all want to look at in particular? So 2. So this is 7 times 2 minus 3. So 7 times 2 to the x. Well, one of the values of x that we're evaluating is -2. So we'll say 7 times 2 to the -2 minus 3. I'll type in the calculator. 7 times 2 to the -2 minus 3. It's because we're evaluating, so one of them x equals -2, so we're replacing x with -2. Bless you. So when we plug this in, we get that this is -1.25. So that's half the answer, because we also have to evaluate it when x is 3. So we're going to do 7 times 2 to the 3rd minus 3. And again, we can type this straight into the calculator. 3rd minus 3 gives us 53. So those would be our 2 answers. So for these first few here, we just got to type them into the calculator, and it would give us our answer. And we'll type them in exactly as it has them. So was there another one that we wanted to look at? Number 5. So 1/5 to the x plus 2. So when we type this in, we'll have 1/5 to the -2 plus 2. And we'll also have 1/5 to the 3 plus 2. And we'll be typing both of these into the calculator. And the first one's going to be 1. So we can say parentheses alpha y equals enter 1/5 to the -2 plus 2. So we can type that in and we get 1. Now we can do it again. So 1 equals enter 5th to the 3 plus 2, which gives us 1/3125. Any other questions on number 5? On how we did this here? So number 1, we're going to do 16 to the -2 plus 3. And we'll do 16, not plus 3, plus 5. And 16 to the 3 plus 5. And see what we get. So the first one is 16 to the -2 plus 5, which gives us 4,096. So we would also do 16 to the 3 plus 5, which gives us this number here. So 4096, and then 429,496, 7296. So 4,294,967,296. Well, we're doing 16 to the 8th power. Any other questions on 1 through 5? So for 1 through 5, we're really just plugging those numbers in, typing it into the calculator, and letting it tell us what the answer is. Guys. Okay. Let's move on. All right, guys, so let's look at 6 through 11. Tell whether the function represents an exponential growth or exponential decay. Now, with 6 through 8, it's going to be considered an exponential growth if the value b is greater than 1. It's going to be exponential decay if the value of b is between 0 and 1. And we're all doing this based off the equation y is equal to b to the x. So if we look at the first one, y equals 7/6 to the x, would this be growth or decay? Growth, because our value of b is 7/6, and 7/6 is greater than 1, so it's going to be growth. Number 7, 0.9 to the x, because it's less than 1. The last one would be growth, because 7.9 is greater than 1. The next one would be growth, and the last one is almost growth. Because for these here, whenever we have the base at e, it is considered growth if the exponent is positive. And it's decay if the exponent, yes. Yeah, it just wanted to erase. So number 9 would be growth because the exponent is 2x. It's positive. Number 10 is decay because the exponent is negative 7x. And the last one would be growth, because it's more based off the fact that 9/10 times x is positive, not so much the 9/10. Any other questions on these here? Whoa, sir. Where's your water bottle? Yeah. No, it's right there. Yeah, I got scared for a second. I thought it wasn't over there. Okay. 12 through 19, we want to rewrite each one of these from logarithmic to exponential form. Now, log base b of x equals y if and only if b to the y is equal to x. And y'all remember going over this. When we went over this first time, we switched from one to the other. If and only if. And I feel probably like for most of y'all, the first time we went through this going from one to the other, it seemed a lot like just magic, or just there's not a real reason why we did this. And since then, let's look at this first one. If I put log base 9 to the base is 9, so we have 9 to the log base 9. What do we know about this here? What happens? They cancel out, yes? Leaving us with 6,561. Well, if I do it to one side, I have to do it to the is equal to 9 to the 4th, yes? Is it now in exponential form? Yeah, that's it. What we were doing with solving is essentially rewriting it from logarithmic to exponential. That is the same as what we would do for this here. That's the same process. So if the switching makes sense, you can do it, or we can apply the base and get to the same result. Questions on this here? Equals? Yes. Because I could put both sides to the fifth power, or to the fifth base. Those are gone, giving us 78,125, and the other is 5 to the 7th. Answer ourselves. But the nice thing with this here is, can we type 5 to the 7th into a calculator? So I could type 5 to the 7th in and see if I actually get 78,125, which we do, which is telling me I have this set up correctly, because it's a way to check it. Any other questions on any one of these here? Either that or they're walking on the roof. Yeah. Yeah. That sounds like the sheet metal.
Over there. How's the roof over there?
Guys, ln of x equals y if and only if e to the y is equal to x. So this was the other one that we had. We're switching it from exponential to logarithmic, or logarithmic to exponential. Well, if I apply the ln of x to the base of e, well, we know that e and ln will cancel out, leaving me with just x. And what I do to one side, we have to do the other, telling us x is equal to e to the 7th, which is the same thing as what we switched. But I think at this point, y'all find applying the base e or applying those there a little bit easier. Questions on this here? Because really, we're switching from one to the other. ln of x equals y, e to the y equals x. So here our y is 7, x is still x, so e to the 7th. So what do we think this 17 is going to be? Yeah, so e and e, those are gone. And that's it. And this is kind of going off the fact that whenever log base b to the log base b of x is equal to x. Okay. So how about 18? E to the y equals 71, because we could put e to both sides. E and the ln simplify out, leaving us with just 71. The other side is going to be e to the y. Any other questions on these here? Yes. Let's look at these here. So we want to rewrite each one of these in logarithmic form. 21. So we want to get rid of this 3, get that out of the exponent. So what we can do is use the switching method of looking at what's the base and how it would change, or if I applied log base 1/5 here, log base 1/5 of 1/5 to the 3rd, our power property says I can move the 3 up front. And what is log base 1/5 of 1/5? is 1. It simplifies. So really the only thing left on that side is 3. But what I apply to one side, we have to apply to the other. That's it. Yeah. Yeah. Any questions on 21? Did that make it a little bit easier than what we did the first time around? Yeah, that's it. Yeah, because it wants us to rewrite each in logarithmic form. So it's in a logarithm form.
So right here you would do log base 125.
So log base 125 of both sides. So the 2/3 would come out front.
2/3 equals log base of 125.
Yes.
Oh, I'm so sorry. Hey, no, they're about to do it.
While we're at it, why don't we go on and do 20? So what would 20 be? So we could 3. Log base 3 of 81 is equal to 4. Yeah. Also. So just doing 20. Which part? Okay, let's I'm going to rewrite it so it's a little bit easier to see. 3, 4 equals 81. So we want it out of exponential form. We don't want the exponent there. 35. But a lot of them are going to be rewriting these, the exponential growth, plugging it into the calculator. Now, and yes. So if I apply log base 3 to both sides, we can move the 4 out front. I'm telling us I've got 4 log base 3 of 3 equals log, yes. Well, log base 3 of 3 is just 1. So really, that's gone, just telling me that.
I was just used to seeing it this way, so when it's flipped it.
Yeah, okay, yes. Because I wrote the log on the other side, yeah. And the whole process of rewriting log base here, so we have b to the x is equal to b to the y is equal to x, converting it back over in logarithmic. This is all we're doing, because I could apply log base b to both sides, because log base b of b to the y is just y, and I'm left here with log base b of x. That's why the formula works. Because really this is all we're doing. But when we covered this the first time, we didn't know that log base b of b simplified to 1. So we didn't use it. We just used the switch method. I don't like shortcuts because of stuff like this here. You guys get this. This is how it works, but you don't know why. Because a lot of times without the why, you're just doing a process because they told you to do it that way. Yes. Yes. One more time. Like this part here? Yeah. Did you make sure to do 1/5 and not 5? So let's see here. Math, log base. So alpha y equals, enter, 1/5. Alpha y equals, enter, 1 over 125. It should give you 3. Because if if it was 125 instead of 1 over 125, it would be negative 3. So if one of these was not in fractional form, it would be negative 3. Let's look at 23, 24, and 25. Yeah, we can ln. So 23, I can put ln. Well, ln of e is gone, leaving us with just 4 is equal to. That's it. So what would 24 be? ln of 27. We can apply ln to both sides. And y equals ln of 27. Last but not least, any other questions on this here? With these here? Are you ready for the next ones? Yes, evaluate each in around 3 decimal places. Type them in. So these here we just type into the calculator. So we could do, well, okay, didn't you already have the answer for 26? It was negative 3. Because log base 5 of 1 over 125 is negative 3. So is there one of these that we want to look at or see how it's typed in? Which one? 28. 1, 2, 3, 4. So log, so we can go math, log base 10 of 0 or point 0.1234 1. Enter. Try again. Is negative 5. Now what is, well, the understood base of any log is base 10, yes? So we could have actually said 0, or not the log 0.12341. Because if the base is 10 log, the log button, the base is understood to be 10. It's one of our common logs. E, yes. Is our irrational number. It's E is approximately 1 plus 1 over x to the x. So do you want 30? So guys, let's look at number 30. So that's the natural log. So for ln, we don't have to do the log base. It's just ln. So we hit the ln button. Alpha y equals enter. Is it 2/7? Because I've 2 over 7, close parentheses, enter. And that's the answer. So negative 1.253. Because we're rounding to 3 decimal places. So negative 1.253. If you put 252, I would take it as well. I'll take either one. As long as you don't give me an answer for this. Something like this here. Because if you give me 5.671, I'm going to mark it wrong. Because as long as you're somewhat within a point or two from the correct answer, so either 3 or 2, 1, something close, real close to it, I'll take it. But once we get hundredths, so if negative 1.27 something, I'm not going to, that's a little too far off. Yes.
I don't know why, but I just wrote it on my paper.
No. No. I'll pass on that. Any other questions on this here? Are we good with these here? Which one? Number 31? So, ln of 4 to the 6th. Let's see here. Make sure I type. So ln of 4 to the 6th, parentheses, enter. So 8.3177 or 8.318. So we type it in. And type it in exactly as it is written. So if the parentheses wasn't after the 6th power, so if we said ln of 4, close parentheses to the 6th, is how the problem was written, type it in exactly as it's seen, because ln of 4 to the 6th and ln of 4, close parentheses to the 6th, give us two separate values. So however, when you get to these here and it says evaluate, type it in exactly as you see it. So for the one we want, 8.318. And that's it. So any other questions on 26 through 31? Guys, let's focus back in. Questions on 26 through 31? We good with 26 through 31? So these here. All right, so we're going to look at 32 through 35 next, which these are some of y'all's favorite problems from this section, yes? By the way, none of these are on the test.
Sounds great.
36 through 39, not on the test. So the expanding and condensing are not on the test. It's not so much that they're more tedious than they are anything else. So all those problems are gone. So we have two problems that we're going to look at next. We're going to look at 40 and 42. We're going to look at these two, and then we're going to be done for today. We'll start with 41 on Monday and look at the rest of the solving, because I'm splitting this up into 2 days. So 40 and 42 is the last two we'll look at today. Yes, so we'll take the test Tuesday. Now, I'm going to make this statement, and this is probably going to help some of y'all. Guys, on the test, any of the problems where there is a variable in both sides, in both of the exponents, these here are going to be our one-to-one. These are going to be our one-to-one problems, which means we really want to write them or get them so that the bases are the same. We want to get it so that the bases are the same, and we set the exponents equal to each other. How can I rewrite 8 as 2 to a power? 2 to what power is 8? Because 2 to the third, 2 times itself 3 times is 8. So now the bases are the same, because 2 times 2 is 4, times 2 is 8. Now what we'll want to do next is distribute the 3. So 2 to the 2x plus 15 is equal to 2. 3 times x is minus, and we get this here. Now, at this point here, and when we went over this, we said since the bases are the same, the exponents have to be the same as well, yes? And at this point, we hadn't done much with solving. Now, what I'm about to write, you don't have to write. What I'm about to write is going to make this make a lot more sense. Because when we get to more of the solving, we would do log base to try to get the exponents to simplify away. What's log base 2 of 2 to the 2x plus 15? Well, these would, so 2x, well, if it'll, on this side here. But what I do to one side, I have to do to the, well, these would, we don't have to do that. Since the base are the same, the exponents have to be the same as, well, this is why. Because I could apply log base 2 to both sides, which would make the bases go away, leaving us with the fact that the exponents have to be equal. That's why this works. Now we just need to solve for x. What do you want? Yeah, we can minus 2x from both sides. Yes. Now that step that I wrote in red, putting both sides to the log base 2, isn't necessary. This explains why this works, why the exponents are equal. Yep. But we could have gone from this to this here without having messed with log base 2. We can just set it, the exponents equal to each other, and solve. Questions on this here? We do need to solve for x. We don't have to apply log base 2 to both sides.
Ignore the log base.
Yeah, because the bases are the same, we set the exponents equal to each other. The reason that works is because if we applied log base 2 to both sides, the bases of 2 are gone, and we just have the exponents left. I just wanted to come back and show you this is why it works. It's not just this is because we say so. It's this here. But any other questions on this? Yeah. 42. So we'll do 41 on Monday. Are the bases the same? Well, yeah, so we can use the ln. Because the reason this works, I could do ln of both sides, and ln of e and ln of e would be gone, which is just telling us 4x plus. But again, our main property is if the bases are the same, the exponents have to be as well. So if we use that, we're just saying 4x plus 7 has to equal 6x minus 35. If I applied ln to both sides, well, we get to the same place. So we can add 35 to both sides. Yep, just erase it, it's gone. 4x plus 42 equals 6x. Which tells. That's it. And for exponents, whenever we're solving for a variable and an exponent, that variable, whatever its value can be, it can be positive, it can be negative, it can be 0. The only times we have restrictions is if we have a negative inside of a log, or the final number when we plug it back in is negative. But